Okay, what this presentation is about is a review of the topics, quick and dirty, I guess, but a review of the topics that we talked about on Wednesday and Thursday. So, first thing we kept going with switches. The MAC address, the MAC address table. We had learning and aging in it. The MAC address or the MAC table, the switch. I'll get the word that I want here in a second. The switch detects the source MAC address on the inbound packet. If it doesn't know what to do with it, it's going to flood it. Remember the flood? Let me put a different color ink on here. It's white. It's going to flood it. So it comes in, and if it knows that the known MAC in the MAC address table, it sends it directly there. D-R-E-C-T-L-Y, directly to it. We have learning on the inbound and aging. The default for Cisco is 300 seconds, 5 minutes. That the MAC addresses will age out in the MAC address table on the switch. We'll look at that a little bit here. We can configure it as absolute or on reuse. So on reuse is we reuse the MAC address in the port. It resets the timer, the countdown timer, so that we renew it. The absolute is it sets it for that, and after the 300 seconds, regardless of what happens, the MAC address is flushed from the MAC table. Flooding. What is flooding? Flooding means basically we would call it broadcast, but they don't like to use that term because broadcast implies the 255 or the all ones in the host portion, broadcast IP addresses. So what's flooded? If the destination unknown unicast, the destination is an unknown unicast. Back up here, it's not a known MAC address, and it's going to be flooded. If the destination MAC address is all Fs, then it's going to be flooded, because all Fs is a broadcast MAC address. Broadcast MAC here. And then switches, we had 3 different types of switches. We had store and forward, cut through, and fragment free. The store and forward get the full frame. They get everything in it. So it can detect errors, best for error detection, and then drop bad packets or bad frames. Bad frames. And it is the slowest because it has to have the full frame into it before it forwards it. The cut through going to be the fastest because all we get is the destination MAC address. And if you remember in the frame, the Ethernet frame, the destination MAC address was the first address that's in there. So as soon as it sees that destination MAC address, it's going to send it to its destination. And then in fragment free, we had that it used the first 64 bytes. Turn my camera on here. Used the first 64 bytes. So it was still fast, but it had some error detection, because most errors are in the first 64 bytes of the frame. A VLAN, logical network, we looked at LANs, local area networks, where we had a bunch of different switches on IP broadcasts. What we did with the VLAN was, and we'll draw this a little longer, we broke it up electrically, logically into VLANs, or virtual local area networks, instead of physical local area networks. The range 1 to 1005 were the normal range, and then 1006 to 4094 for the extended. 1 was the default, which was also what's called the native, which was used for the untagged frames. Untagged frames. 1 default, can't make it go away. We can change the ports from where they are, and then with 1002 to 1005 were all put in there for us by Cisco. So the default VLAN is 1. The native VLAN is where the untagged frames go. And ISL, if you ever see the term, and I don't think you will anymore. It had a 26-byte header, I think, that went on it, and that's the only thing I've ever seen asked about it. CDP and LLDP, Cisco Discover Protocol, is proprietary. LLDP is the standard, and what this does is a layer 2 protocol used to detect directly connected devices. It can be directly connected because they're layer 2 devices. It can't go out of that network segment when you do those, when you look at those. Ports on the switch. When we talked about VLANs, we had access ports, and access was like end units. We'll say end units, and we had one per VLAN. So we can have one on one per VLAN on one VLAN. So that if we had a bunch of computers on VLAN 20, they would, each of those ports would be configured for VLAN 20, and then that would create the broadcast domain. The trunk port is on all the VLANs, and if you recall, the trunk port is a thing that went between the switches, and if we had multiple switches, it would keep going, and it carried traffic. The trunk port carried traffic on all VLANs. And that's what makes the inter-switch connectivity work, so that if I have a VLAN 20 guy here and a VLAN 20 guy here and a VLAN 20 guy here, they can all talk to each other because the VLAN 20 tag packets go across the trunk. If I have a 30 here and a 30 here, they can talk to each other, but 30 cannot talk to 20 unless we put a router in here. We need a router in order for that to work, because it's just like any other broadcast domain, we have to have something in there to do that. A voice VLAN broke the rules. It's a rule breaker. It's the only time two VLANs can be on an access port, and we looked at that. We had the phone here and the computer attached to the phone, and then that was attached to the switch. What the phone does, this is the phone does, is sends the packets from the computer directly to the switch, and it doesn't tag them. So the switch is going to put the VLAN tag on it. The phone puts the voice VLAN tag on the voice packets that go out of it. So we wind up with two tags on the same access port on these things. Multiple switches, trunk ports, we talked about that up there. Trunk ports, .1Q, they call it a shim. If you remember, we put it right in the middle of the Ethernet frame, and it was a 4-byte shim, or a 4-byte corruption of a 4-byte area in there. So we put that in. ISL, Inter-Switch Link Protocol, is a 26-byte header. That's a Cisco proprietary. And again, the new switches don't support it. And I think that if you use, I don't know about those, if you download Packet Tracer and try to use ISL and Packet Tracer, it's not going to work in it either, because it is a defunct protocol, but they still put it in. Yep. The reason they still put it in, switches don't get replaced a whole lot. So what we look at is that if you've got some really, really, really old switches, you may have the ISL protocol. It's kind of unlikely, but I guess still a possibility. Then we had routing concepts, and then we have packet handling. We had routing, which was the route table, and then we had forwarding or switching, where it came in on one interface, interface 1, and then it was switched to interface 2 to go out the correct location. And encapsulation, we talked about that. We'll deal more with encapsulation later. The one time that we did do encapsulation was the router on a stick, which will still show up here in a minute. But the router on a stick, we had to use the .1Q encapsulation on it. The routing encapsulations, the packet handling routing encapsulations. And we're going to use IPv4 for ours, and then we're going to use TCP or UDP for the transport layer. Again, in the OSI, which again was the last review, where each layer supports the layer above it. And then we have metrics in that. We had like a, we'll do a, this is going to be a RIP, the worst one, a 120-5. The metric that we used here was hop count. 120 was its administrative distance. So the metric is used to find the optimal path, determine how desirable a path is if we have multiple paths, and it's a standard for the protocols. Each protocol has its own metric. EIGRP was a hybrid, I think, multiple, and then OSPF was cost, so we had each of those. When we did routes, we had the level 1 and the level 2 routes. We break routes up into networks and subnets, and whichever is the longest prefix is going to be the preferred route. And the longest prefix is the number of ones in the subnet mask. Okay, so with that, a little bit of that. Next, routing concepts uses the longest prefix, which we talked about, which was the subnet mask ones in the subnet mask. The frame rewrite was at the MAC address. The source and destination IP don't change. The MAC, the frame rewrite for the MAC, changes at each device, because they're looking for, at the layer 2, they're trying to find the location from one to the other. We talked about static and dynamic routing. Static, we did the IP route command, and then to the network, and / well, and then the mask, we'll say the mask, and then the next hop, or the outbound interface when we did those. Dynamic routing, depending on the protocol that we used, each of them would make their own changes. Statics, if we have changes to the topology, we have to go in and redo the routing, the route table. Dynamic, we have changes, they automatically detect that. And then we talked about RIP, small networks. 15 hops is the max, 16 equals infinity. And that's the way that we poisoned a route. ICND, right? Poisoned a route. The routing protocols, we had C for connected, S for static, R for RIP, D for EIGRP, and O for OSPF. And those really are the ones that we're going to use. Gateway of last resort is a default route. Gateway of last resort, or a default route, if we don't have in our routing table something to send it to that network, we don't have that network in our routing table, then it'll use the default route and send it to that location. If we don't have a default route or a gateway of last resort, it'll drop the packet. Administrative distance is how trustworthy is something, and we had, what, 120 was RIP, 110 I think was OSPF, and 90 was EIGRP. Connected was 0, and static was 1. So it's going to trust us over the routing protocols. Not sure that's always a good idea. And the metric was what we used to get there. We talked about the gateway of last resort, a default route. If something doesn't have a destination in the routing table, then the gateway of last resort or the default route is used. Split horizon, route poison, passive interface. Split horizon is if we won't send it out the interface it came in on. We won't tell a router about a route that told us about it. It's kind of like whispering. Somebody whispers a secret, you won't tell them back the secret. You won't tell them back the route. Route poison, we talked about up here, was when we assigned 16 as the hop count on this thing. And passive interface just says don't play. Don't update, and I think in RIP it's just don't update the interfaces. In OSPF, I think was the specific in the slide, said that it will just not play in the game at all. Each of the protocols a little bit different. Routing concepts here more. 7, we had the router on a stick, which was going to the switch that had multiple VLANs in it. This was a trunk port, and this is going to be an Ethernet port on the switch, and we're going to use .1Q as the encapsulation protocol. All of the VLANs go on the trunk port, so they all go up here. They get routed internally because we now have directly connected networks on this thing, so they get routed up here and then routed back down to the correct VLAN where it's destined. Floating static route was to back up an automatic route. If you ever have a word go away from you, a dynamic route. Thank you. So to back up a dynamic route, and if we do that, we have to change the administrative distance, because the static route is going to be administrative distance of 1. If we're backing up a EIGRP of 90 and we put the static route in, it's going to displace the dynamic route, the routing one. IPv6, we had to give the IPv6 unicast routing command in order for it to work on a router. They're still all configured for 4. I'm sure that'll change in the future, but right now we have to enable IPv6 routing. Access control list. In spite of the fact that we kind of talked about 3 things, there are 2 types, which are the extended and the what was the other type? Standard. Standard and extended list. The standard is close to the destination, SD, so the extended are going to be closest to the source, and the extended are a topic of ICND2. So we have 2 types of access control list. The statements are in order from top to bottom, and the packets check the statements from top to bottom to see if something applies. If something applies, it executes that one and doesn't look any further. If it's a deny, it's automatically denied. If it's a permit, it's gone. It doesn't check anything below that. That's where order becomes significant. If it goes down the list and nothing applies, then we have an implied deny at the end of the statement, which will deny everything. So you have to have at least 1 permit statement in an access list. Permit. There you go. So we have the standard and the extended. The standard was the source IP only. And the extended, which we will again talk about later, we have the source and destination IP as well as the ports that we can use in here. We had named and numbered. Named is easier to keep track of. Name is to keep track of what's it used for. It's also easier to edit because it put those numbers in, the 10 and the 20 and the 30 and on down the line, so that if we wanted to add something in here, we could put in 15. The numbered list, if we put a new statement in, it goes to the bottom of the list. Notepad copy and paste works on that very well. NAT is a security mechanism, and that was the first statement that they had. It's also, and this is my statement, a way to extend the IPv4 address space. Of course, proxy servers are also. We had dynamic NAT and static NAT, and then we had overload, which was PAT. The dynamic, we had a pool of addresses. Static was a 1-to-1. And then overload, if we run out, overload is actually port address translation. If we only had 1 address, we would NAT to our interface and then give it the overload command, and it would automatically go into port address translation. A whole lot more ports than there are IP addresses. typically in the world that are available to us anyway. And then we talked about maintaining the infrastructure for a little bit. We had SNMP, Simple Network Management Protocol. We had version 1, version 2, and version 3. Version 3 had security 1 and 2. We didn't really say that, but it has a community name. They talk about has a little password on it called a community name. Yeah, well, it's in clear text, so all you got to do is run a sniffer, and you can see that. NetFlow was a Cisco protocol that we use to watch traffic flows, and I guess it's aptly named as NetFlow. So we could see the traffic, and in the presentation we had some images of what the console would look like. Syslog is when we send the logs to a server off of the Cisco device. And we looked at that real quick, and that's really what logging. The command was just logging, and then the IP address of the syslog server. It had to be running someplace. SDM, which is Security Device Manager, was a GUI interface. The current version is ASDM. I don't have a copy of it, so I don't know what the difference is. But SDM, you saw you could monitor as well as configure, do an awful lot of configurations. It will write an awful lot of configuration commands for you. You can look at those, should look at those before you install them to be sure that something didn't happen. Auto install, we had to have it set up. We had to do our planning to do it. It had to have a DHCP server, if you remember, a DNS server, and a TFTP server. It's designed to do an auto install from a remote location so that we don't have to be there. Somebody can plug in the router, hook it up to the network, and then DHCP, get an IP address, DNS later on, TFTP to download the configuration file, and then DNS to tell it what its host name is. iOS licensing, we looked at the process there to getting the keys and then going to Cisco and downloading the license and then installing it on the device itself. The logging types, we had console, which is the default terminal, remote terminal, which we had to do, and then we could put it in the buffer. Syslog or SNMP all could be used for that. And we talked a little bit about time zone. If you're in multiple time zones, you need to have that set so that when you start doing a log analysis, the times make sense. Maintaining the infrastructure, here we had the loopback addresses and the loopbacks, and they talk mostly about T1 on that, but loopback is a troubleshooting way, and we can put interfaces. Also, they've talked about making an interface, and the command is config interface hello whatever 1 2 3 4 whatever number you want it to be, and then you put an IP address on it to do that. iOS upgrades we talked about, and I gave you my experience that didn't fit. When you do this, make copies of what you're doing before you do it, because if it doesn't fit, it could become an issue with you. iOS recovery. Or if you get ROM-mon, when you start the machine and you get ROM-mon, we did that with the password recovery. You get ROM-mon, that's when you say uh-oh, and then you want to go to Cisco and get the step-by-step. You have to go into ROM-mon mode, set it up. We can do with a TFTP server. We put the IP addresses on it, copy it from the TFTP server to the flash memory area of the device, and then we can go on from there. We could also, if you remember, we don't do a configuration of that, but we can boot to a TFTP server that has the iOS. So that is one of the ways around it. Password recovery, what we did is tell the device to not load the startup config. To start up, we didn't load, and then once we got there, it tried to go into setup mode. Once we got there, we would copy the startup config into the running config, because if we just changed the password and saved it, and then copied run start, all the other configurations would be gone, all the IP addresses and anything else that we had in there. would be gone to do that. The 2102 I think was the standard, and 2142, even though I got it backwards, 2142 was the one that said don't load the startup config file. The configuration register tells the system where everything is. Where is the iOS? Where is the config files? And we can specify those locations by changing the configuration register. Mostly what you're going to use is 2102 and 2142. If we were going to do the iOS someplace else, we would have to do it like on a TFTP server, because the 2102 says that, hey, look into Flash for the iOS. 2102, look into the Flash and look into NVRAM for the startup config, while 2142 says look into Flash for the iOS, but don't check for the startup config file. And then the troubleshooting, ping, trace route, terminal monitor, where we can monitor things. The other troubleshooting tool that we talked about was Telnet. Telnet, where we can Telnet to a service, to a application layer service, a layer 7 in the OSI model service, to see if it's actually running. Ping and trace route, check layer 3 for us. And I think that is the end of the review. Are there